Students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 6, Perimeter and Area of grade 6 Mathematics of the new NCERT textbook Ganitha Prakash. And now we are going to deep dive into more of perimeter in this chapter, in this particular video. So let us understand what is given in this deep dive situation. So in races, you would have observed that there is usually a common finish line. It has to be, right? Because it has to be fair enough for all the runners. Now here there are two square running tracks. You can see there are smaller square with side 100 meter and the larger square with side 50 meters each. Okay. Now the common finish line for both the runners is shown. This is the common finish line. This black line which you can see, right? These two flags are shown, the orange and the green flags. So the common finish line for both the runners is shown by the flags in the figure, which are at the center of one of the sides of the track. Now if the total race is of 350 meters, then we have to find out where the starting position of the two runners should be on these two tracks so that they both have a common finishing line, that is, they should both run 350 meters only, right? Then only the race would be fair. So this you would have observed on your sports day, that your teachers, they make 4 tracks for relay races and all, right? And their starting positions are different. So how do they decide? So next time, if you understand this, you will be able to help your teachers in marking the track. So what are we supposed to do? Mark the starting point of the runner of the inner track as A and the runner on the outer track as B. Okay. So first what we'll do, we'll find out the perimeter of both the squares, right? So suppose we take the perimeter of the smaller square. We take the smaller square as P1 and the larger square as P2, right? So P1, it's a square, so 4 into 100, the side is 100 meter, so 400 meter is the perimeter for the small square. And if we take P2, 4 into 150, so that is 600 meters. This is the perimeter of the larger square, that is the P2 square. Right. Now we want the race to be 350. So what we'll do, we'll subtract the perimeter 350 from the perimeter of both, so that we can go, we can calculate it from the finishing line. We can go backside and track it so that we get the starting point. So like 400 minus 350 is 50 meters. So first we are doing for the smaller track, that is the smaller square, P1 square, right? So now if you observe this line is exactly in the center. That is written, that's in the center of the two sides of the track, the finishing line, right? And the complete race, if we count, is 400 meters, but we want it 350 meters. So we subtract 50 from the finishing line. So here, this is 100, total is 100. So each will be 50-50. So if we subtract 50 and if we mark this point as, for the inner track it is A. So we mark this point as A, right? So now if this is the starting position for the smaller square, this is 100 plus 100 plus 100 plus 50. So he will cover up, the person will cover up 350 meters exactly, right? So this will be the starting point for the smaller square, right? Now we look for the larger square. So for the larger square, the perimeter is 600. So 600 minus 350. Wow. We are doing a reverse calculation, okay? So that would be easier. There can be many ways of getting the starting line and you can do it in your ways, in your own way. Okay. So you have to think backwards in this case. So now 250, we have to go 250 backwards in this particular square, the larger square. Now 250 meters backward means, now if we see this is 150. So each will be 75, 75, right? So if we go back, this much is 75, this is 150. So 150 plus 75 is 225, right? So till here is 225. So 25 more we have to go back so that we can decide the starting point. Now, how will we get 25 over here? So if we just take the center, if we use a scale and mark this point here 75, and we divide this 75 into 3 parts, equal parts, right? So we will get approximate 25 meters. So this point which I have marked will be point B, because this is 25 meters. So 25 plus 150 plus 75 will be total 250 meters. We have gone backwards. So if he starts from here, then this person will also cover up 350 meters, right? Such an interesting question, and you can actually try this out in your school playground with the help of your sports teachers. It will be fun, and you will also understand that how the races are fair, because though we know that the starting positions are different in the 4-track races, the relay races, or 400-meter or whatever, depends on the ground size, we always feel that the one who is getting the shorter circle will finish it faster. But when you do it yourself, you will understand that it's not so, right? So we'll now continue with this video with the next topic, that is estimate and verify. So estimate and verify. So what is given over here? Take a rough sheet of paper, of newspaper, or you can take any paper which is of no use. Make few random shapes. You can make triangle, rectangle, square, or even any irregular shape, right? By cutting the paper in different ways. Estimate the total length of the boundaries of each shape, and then use a scale or measuring tape to verify your answer, right? So I'll show you one example, and then you can try more to get an idea. So I've taken a sheet of paper. First we will estimate. So let us see that this length of this rectangle is little more than our small scale. Our small scale is 15. So maybe this is 16, 17. So let us take it as 16. Okay, the length as 16. Okay, and then the breadth as 6 centimeter, around 6 centimeter. So we can find out the perimeter. 16 plus 16, that is 32. 32 plus 6 is 38. 38 plus 6 is 44. So 44 is the rough estimate for this particular. Let me write down so that we can confirm when we measure it with the help of a scale. So length we have taken as 16 and breadth as 6. So 16 plus 6, we can do it other way also, is 22. 22, 2 is 44 will be the perimeter of this shape. Now let us measure, verify with the help of a scale how close we are to the estimate. So this is still here is 15. Then we measure a little more. So this is around 15 plus 3 more. So this is 16. Sorry, 18. We had taken it as 16, right? So a little close to the estimate. Now we see the breadth. Breadth is around 7 and we have taken it as 6, right? So this way you can just there the perimeter in estimated perimeter was 16 plus 6. I'm repeating that again, and that is 22. 22 2 is 44 meters, right? And the real perimeter is So 18 plus 7 is 25 and 25 twos are 50 meters, right? So that's the difference between our estimation and the real perimeter. So you can take such shapes and verify your answers. Now let us see further. Akshi says that the perimeter of this triangle shape is 9 units. And Toshi says it can't be 9 units, the perimeter will be more than 9 units. Again, there is a matha pachi between Akshi and Toshi, right? So, she's Akshi and she's Toshi. Now, let us see why they are saying so. So, what they have considered this as 1 unit. So, here 1 plus 1 plus 1, this is Akshi's thinking. So, 3, again here 3, and here also 1, 2, 3. So according to Akshi, 3 plus 3 plus 3 is 9 meters, right? But what happens in the real scenario? Like suppose if it's a I form a square over here, right? All the sides of a square are equal. But what if in this case also, suppose I form a square over here. So in that case, okay, that this all sides will be 3, 3, 3. But the line which is formed here in the center is diagonal. It's the diagonal of the square. And the diagonal of a square will always be little longer than the side. Okay. So that is why what Toshi is saying, what is she considering here? These two as 3, 3, fine. This she is agreeing with. Why is she saying it will be little more than 9? Because this will not be 3, this will be little more than 3. Okay, maybe 4, 5, whatever, we don't know, we need to measure it. So without measuring also you can say this will be little more than 3. So naturally the total will be more than 9. So Akshi has a reason to say 9 units, while Toshi has given out the reason for this is a diagonal, so she is saying that it is more than 9 units, and Toshi is correct in this case. Now this figure has lines of 2 different units length. Measure the length of the red line and a blue line. Are they same? We call the red lines as the straight lines and the blue lines as the diagonal lines, right? So 6 straight lines plus 3 diagonal units. So in the short form we can write as 6s plus 3d units, and that way you can and you know that the diagonal's length is little more. So that's why this again it is correct. You can use this formula to measure this red lines and the blue lines given over here. Now with the same understanding, here there are some more diagrams given, and we need to find out the perimeter in terms of straight lines and diagonal units in all these cases. Okay, so like in using this formula, 6s that is for the straight lines and 3d for the diagonal units or the diagonal lines. Okay, so let us see the first question here. The first purple lines, if we count the straight lines here, 1, 2, 3, 4, 5, 6. Then here also in the center 7 and 8. There are 8 straight lines. So we write it as 8s. Plus how many diagonal lines are there? 1 and 2 only. So 2d. 8s plus 2d. We need to write this kind of formula for all of them. And don't forget to write units. Whatever is the unit. In this case, we are just writing units because we don't know whether it is centimeter, meter, whatever. Okay. So I'm writing units over here. There is less space. Now in this case, let us count the straight lines first. So if we count the straight lines, 1, 2, 3, 4 only. Sorry, these are the diagonal lines. Straight lines are this 1, This color is not visible, so I use this. 1, 2, 3, and 4 straight lines. So 4s plus these are the diagonal lines. 1. Let me use another color for diagonal lines. 1, 2, 3, 4, 5, and 6. So 6D. 4s and 6D. Now let us count the straight lines in this case. So if we start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12s plus the diagonal lines. So for diagonal lines, let me use red color. So if I start from here, this is 1, 2, 3, 4, 5, and 6 diagonal lines. So we will write 12s plus 6d units. Here also you need to write units. And the last diagram, first let us count the straight lines. So if we start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly here 10, 11, 12, 13, 14, 15, 16, 17, 18. These are the straight lines. So we write 18s. And then we count the diagonal lines. So if we see here 1, 2, 3, similarly 1, 2, 3. So total 6D units for this shape which is written as N. Right? So such a nice way of writing the formulas and finding out the perimeter for such shapes with straight and diagonal lines. Right? So we'll continue with this chapter in the next video. Thank you.